What is in the universe? That's our goal this semester, to understand what is in the universe, the things that are out there, how they interact, how we know about them, how we can learn more. So let's start with this question. What is in the universe? And let's start answering that question from planet Earth, from our home planet. You already know a great deal about planet Earth. You could tell me its physical properties, geography, climate, and all about the inhabitants, the people, how they interact, the other life forms, the way things cohabitate. There's just a tremendous amount of information that you already know. In fact, all of the subjects that you study in school are contained on this planet. So all of your education has been learning about life on this planet. And what we're going to do this semester is metaphorically leave the Earth to think about the things off the planet, our celestial neighbors, and try to figure out as much as we can about our place in the universe. Now, the furthest people have been is to the moon, and that actually occurred quite a long time ago now. It was in the end of the 1960s, 1969, July 20th, the Apollo 11 mission landed on the moon. That was the culmination of a long journey, a race between the United States and the Soviet Union to be the first to leave the planet. Now, for a while, the Soviet Union led that race. They were the first to launch a satellite. They, in fact, had the first woman in space. But ultimately, the United States was the first to successfully land a person on the moon. You probably know the first person to walk on the moon was Neil Armstrong, and the second right behind him was Buzz Aldrin. There were 3 people on that mission. Can anyone name the third? I'll give you a second to think about it. His name was Michael Collins, and he had the honor of being on the mission, but the misfortune of not being able to go down to the Earth. Someone needed to stay in the spaceship in orbit around the moon to help those astronauts get back to the Earth after their mission was completed. And so those 3 astronauts were the first people to get to the moon, and 2 of them walked. To date, 12 people have walked on the moon. The last was in the early 1970s. And nobody has left the planet, at least left the orbit of the planet since then. We've sent astronauts into space in orbit of the Earth. But no one's been to another world since that time. And excuse me, there's a lot out there to explore. I imagine everyone can name all the planets in the solar system. Maybe when you were growing up, Pluto was still one of those planets. Now we consider Pluto a dwarf planet. And there are 8 regular planets in the solar system. The Earth is one of those. We'll spend some time in, I think, week 5 talking about the solar system in more detail. But for now, you can see on this graphic the order of the planets. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. And then there's a collection of dwarf planets, and we'll probably discover more of those over time. There are also other things like smaller asteroids and comets within this one solar system. So a solar system is the collection of things that lives around a star, like our sun. Our sun, we're going to spend a whole week talking about that. The sun is an average-ish star. And we'll see what that means when we delve into the properties that stars have. But it's not particularly hot. It's not particularly bright. It's also not very cool or dim, not very large or small. It's sort of in the middle of a lot of important categories. You'll actually do a little bit more detail, get a little more detail on the solar system itself before week 5 in this week when you do the plotting data lab, where you will look at their distance from the sun and some stuff about their temperature, the surface temperature of the planets. Now, to leave the solar system, we'll find ourselves among the Milky Way galaxy. Now, the Milky Way has been known for a long time. As early as people started looking up at the sky, they could see the Milky Way. We don't notice it as much now because there's so much light pollution. But if you've been able to see the Milky Way, it's really a spectacular sight. If you get to a dark place on a moonless night and you look up to the sky, let your eyes adjust to the darkness, you'll see this swath of light sort of stretching from one end of the sky to the other. Now, with a long exposure camera, you can get a picture like you see over here. This is obviously not what you would see with your naked eye, but you would be able to see a lot of the details that are here. Now, we've known about the Milky Way for a long time, but we didn't know what it was until relatively recently. And what it is an entire galaxy in which we are one star among billions. And so galaxies are tremendously large collections of stars. And we'll find later on when we study the Milky Way that we're located sort of in the suburbs, is the way I like to say it. We're in the suburbs of the galaxy. And we'll talk about how it's organized and why it has the shape that it does and why there are like these bright regions and the dark regions and what that all is. But if we leave the solar system, we find ourselves in this Milky Way galaxy of billions of stars. Now, a little bit more about stars. Stars form from clouds of dust and gas, which we call nebular clouds. In fact, any cloud of dust and gas that we see in space is called a nebula. They're not all forming stars. We'll see another nebula in a minute. But this one here, the Orion Nebula, is one that you can see with a telescope. And later in the semester, we'll focus on this a little bit more. But the Orion Nebula is forming stars currently. There are currently stars forming from this cloud of dust and gas. Within that cloud, millions of stars will form, and most of them will form in clusters. This picture right here is of a cluster of stars. You can think of them as sort of mini galaxies. They're not to the scale of a galaxy, but they're thousands of stars or hundreds of stars or dozens of stars that are all kind of in a clump. They're gravitationally bound. They're in orbit around one another. Stars tend to form in these groups, these star cluster groups. The sun is not in a star cluster. It's sort of a single star by itself, so the stars also form that way. But most of the stars form in clusters, and we'll find star clusters really useful to study, to learn about the properties of stars and how they evolve over time. Now, I said we'd see another nebula. This is the other nebula. This is a different sort of nebula. Stars are not forming here. This is the result after a star has exploded, what we say as a supernova. Stars will live for some amount of time. We'll talk about later on how long a star lives and what determines how long it lives. But some stars will eventually explode. The sun is not one of them. But some stars will, and this star exploded, I think something like 1,000 years ago, and left us with this nebula, which is known as the Crab Nebula because it's shaped sort of like a crab. We'll look into detail about how stars go through their life cycles, what leads to a supernova, and in particular, focus in on the center of the Crab Nebula. There's something really interesting happening right there. Okay, so we've left the solar system, we've gone into the Milky Way and found stars, and there's different kinds of stars that have different kinds of lives. If we leave the Milky Way, we end up in a sea of galaxies. So stars can come by themselves, they can form into clusters. The collections of stars are bound into galaxies, and then there are billions, in fact, of galaxies in the universe. Our largest near neighbor galaxy is called the Andromeda Galaxy, and that's what you're seeing right here in this picture. This is something you can also find with a telescope. Back in the image of the Milky Way from a few slides ago, every dot of light in that picture was a star, except for the ones that were themselves galaxies, and the Andromeda galaxy would be one. Don't ask me to say which one it is, but I can find it on a clear night and see it in the telescope. You wouldn't see the color that you see here, but you would see this general shape. There are billions of galaxies just like this out in the universe. And at the end of the semester, we'll study those other galaxies and what they tell us about not how stars evolve, but how the universe as a whole has evolved, and briefly get into the Big Bang hypothesis, the idea that the universe formed in this Big Bang explosion and has been expanding ever since.